Hi, Yanis here, and this is a coding intro on a new project I've been working on the last couple of weeks, which is named Annotation Processors for Kubernetes and OpenShift, or Ap4k if you prefer to use an acronym. The goal of the project is to keep Java developers happy and focused by lifting off their shoulders the burden and constant annoyance of hacking and maintaining Kubernetes manifests. This is achieved by providing a set of Java annotations and processors for generating, customizing, and testing such manifests. Now this is cool because it keeps Java developers away from YAML, JSON, and XML. It's also practical because the compiler validates the configuration and the developer is guided by the IDE through code completion and syntax highlighting. Most importantly, it's something that's accessible and available to all Java developers, regardless of the build tool that they are using, because it's something that you can use with Maven, Gradle, SPT, Bazel, anything. The project is available on GitHub and the binaries on Maven Central. The latest release is 0.1.2, and it's what I'm going to use today in order to demonstrate how you can get started, how you can use annotations to customize manifest, how you can build, deploy, and test. For the sake of this presentation, I am going to create a Spring Boot application from start.spring.io. It's going to be a Java application built by Maven that will live inside my demo folder. Once the application is ready, I can jump into my pam.xml in order to add the Ap4k Kubernetes starter for Spring. The group ID is io.ap4k. The artifact ID is Kubernetes Spring starter, and the version 0.1.2. I can now jump into the main class, and I can add the Kubernetes application annotation on top of the demo application class. Now, by building the project, I expect to see a folder generated under target classes. The folder is expected to be called metainf ap4k, and it should contain a kubernetes.json and a kubernetes.yaml file. Now, the kubernetes.yaml file contains a simple deployment for my application, which is a resource that can be further customized through the Kubernetes application annotation. I can add, for example, things like envars, volumes, mounts, or anything. I will just add a label for now that will have the key generated by and value Ap4k. And by rebuilding the application, I expect to find that label being present in the deployment. Indeed, I can see that the deployment has the generated by label. If I have a typo on my configuration, the IDE can easily detect that and can provide me a hint that something is wrong and even suggest possible solutions. For example, it suggests that I can change to image pool policy, liveness probe, ports, PVC volumes, whatever. I'll switch back to labels. And the next thing that I would like to show you is how Ap4k can integrate with the framework that you're using. And for the sake of this demonstration, I am going to create a new file that's called controller, and it's going to be an actual REST controller. Now, by adding a REST controller, Ap4k will be able to detect the REST controller and request mapping annotations, and will realize that we are talking about a web application. When it detects a web application, it will expose container port 8080, and also it will create a service that is going to point to the container port 8080. Let's see that in action. As promised, the manifest now contains a service, and it also contains a container port. Oh, and I forget to mention that it will also register a readiness and a liveness probe that will use the port 8080 in order to perform their checks. Now, I mentioned that Ap4k is something that you can use to generate Kubernetes and OpenShift manifests, and at this point I would like to migrate my application to OpenShift. And the first thing that I need to do is to change the dependency and use the OpenShift starter, and then to change the Kubernetes application annotation to OpenShift application. By rebuilding the application, I expect to see, instead of a Kubernetes JSON and a Kubernetes YAML file, an OpenShift JSON and an OpenShift YAML. And here they are. Now, the OpenShift YAML is pretty similar to the Kubernetes equivalent, but instead of having a deployment, it has a deployment config and some other minor differences. I can try and deploy that to my target OpenShift cluster. I'm using an OpenShift installation that currently has an active project named IOCaml, which is, as you can see, empty. No deployment configs, no deployments, anything. I can apply the generated configuration to that environment. This is similar to performing a noisy create or a kubectl create, and I can see that the deployment has been created. One thing that I notice is that I have 0 replicas at the moment, and this is normal actually, because I have no images, so no replicas and no instances of my application can actually exist. In order to build an image, I will have to jump back to my demo application and enable the S2I build. And by enabling the S2I build, I'm triggering the generation of a build configuration and the appropriate and required image streams. The build configuration is here. And so are the image streams. The resources have been applied, and all I need to do is run something like OEC start build, etc. But I can also include it as part of my build by appending the Ap4k build equals true system property. And this will tell Ap4k to register a hook that post-compilation it will trigger the actual build. So I expect, after my build is complete, to see the artifact being uploaded to OpenShift so that an S2I binary build is performed. The artifact has been uploaded and the build has started. The build is done, And if I jump back to my console, I should see a replica started and a pod for my application to run. I can inspect the logs of my pod and I can see that my Spring application has been successfully started. Now, how do we check and how do we test this application? For our testing purposes, Ap4k provides JUnit extensions for Kubernetes and OpenShift, and I will demonstrate how we can use the OpenShift one. I am going to create a new file under src test java example demo, and I will call it demo application it.java, and it will be a plain JUnit 5 test. In order to use that, I will have to add the JUnit extension in my dependencies. Oh, I also need to set the scope test. And I also need to add a failsafe plugin configuration so that I can tell the failsafe plugin to pick up all test classes that have the IT suffix. I'm jumping back to my application, and now I should be able to annotate my test class with the OpenShift integration test annotation. And by adding this annotation, I'm telling JUnit that I want for each test that bears this annotation to find the generated manifest, apply the generated manifest in the target cluster, perform an S2I build, and once the build is done, to run the actual annotation. Some extra goodies that the extension provides is that it allows us to use the Kubernetes client that points to the test environment, and also to inject the actual code that contains the application. Now, I'm going to use this pod in order to perform a port forward from the container port to my local host in order to perform an HTTP GET and verify that I get back the expected result. So I'm creating a local port forward using the client on the pod with name same as the injected pod. And I will port forward port 8080 on localhost. Now I'll wrap this in a try-catch block. And inside this block, I am going to create an HTTP GET. I don't want to perform HTTP GET on port 8080, but instead I want to use the local port from the port forward. Now, I need to perform some imports like the OK HTTP client, the request, the URL, the response, and finally to assert that the response that we get back equals to hello world. Now, if the demo gods are kind to me, that should be enough. Before I run the test, let me jump back to the environment and make sure I wipe the application so that it doesn't mess our tests up. There we are. npm clean install. I don't need to trigger a build. The JUnit extension will do that for us. So the test has been started. It applied the OpenShift.yaml to the target environment. It created the image streams. It created the build config, and now it triggered the build. It should take a while, but once the build is done, it will wait until the target pod is in ready state, and when the pod is ready, the test method will get executed. The build is done, and now we are waiting for the pod to get ready. The test has started. We see that the port forward has been created, and the HTTP request was executed, and the test was successful. Now, before I close this demonstration, I would like to recap. I used Ap4k in order to generate manifest for Kubernetes and OpenShift. I played a little bit with the annotation in order to customize the resources. I integrated my application with Spring Boot. It's worth mentioning that there is support for other frameworks too. For example, Thorntail is supported, and also Micronaut. And finally, I used the Ap4k JUnit 5 extensions in order to run an integration test for my application. Ap4k is a very new project. I'd like you to use that, provide feedback, contribute, and keep in mind that new features come in every day, so make sure you check back often. I hope you enjoyed the presentation, and till next time, bye bye!